Hello students. In the last lecture, we discussed about what is called as scalar triple product. Okay, and in the geometrical representation of scalar triple product, okay, I just want to revise it again in a short time. So that time, what we wanted to show that scalar triple product represents the volume of the parallelepiped. Correct? So over here, I just drawn a parallelepiped. Correct? So this part is my vector B. This is vector C. Right? So this part becomes what? Correct? I'll name it O L M N. So this O L M N becomes base of parallelepiped. Correct? And this side I'll try and show vector A. Right? And if at all I draw a line like this, a perpendicular, right? This angle is angle theta. Correct? So if at all I draw a perpendicular here and here, this part is going to give me what is called as H is equal to mod of A cos of theta. Right? So what is the volume of parallelepiped? Volume of parallelepiped is equal to base into height. So what is the base of that? Given by the plane OLMN, which is vector B and vector C. Vector B is here, vector C is here, vector A is over here. Right? All are starting from the same origin O. Vector this, vector B, vector C and vector A. Correct? And what is my height? Height is vector A cos theta. Correct? Moment I say A cos theta, this is nothing but A dot B cross C. That's the reason scalar triple product represents the volume of parallelepiped. One shouldn't have this difficulty. That's what I thought. I should repeat it again for everybody before I go to the next topic, which is vector triple product. Right? So after finishing scalar triple product, my job is to mention, sorry, I forgot this part. This is B cross C. This is B, this is C, this is B cross C. So next will be vector triple product. So in STP what we had? Scalar triple product. We had three vectors. Which three vectors? Vector A, vector B and vector C. So what we said? A dot product of one vector with the cross product of other two vectors gave me scalar triple product, which means the product of these three vectors was a scalar, that's why scalar triple product. Now when you have three vectors, again A, B, C, correct? You say that the cross product of one vector with the cross product of remaining two vector gets me a vector again, that is called as a vector triple product. Right? How we will show this? This will show you by a simple diagram, which I draw it first on the book. Right? So over here, my job is to show that how I am going to get this is one plane called as O L M N. This is origin and this part is my vector B. Correct? Now over here, I'll have to interrupt this part. Correct? So initially, my job is to show this to be vector B and this part to be vector C. I'll shift and keep it over here, origin. So this is my vector C. This is vector B. Okay. So I am going to get my plane over here. So this part is going to give me what is called as B cross C. This is B vector, this is origin O. Correct? So this part is what? This is my plane right. This is plane OLMN in which I have vector B and vector C, and this part is my vector B cross C. Okay. Now suppose from this point itself I have a vector A over here. A vector A over here. Correct? Then what will I show? I show a part like this and join them together. Perfect. So this is become what now? This is plane of vector A and B cross C. Vector A is here, vector B is here, vector C is here. This plane OLMN in which I have vector B and vector C. This part was B cross C, cross product. Vector A is over here. So now where should I get my VTP or a vector triple product? Exactly perpendicular to this. So somewhere over here I will be able to get my A cross B cross C, right? Perpendicular to this. So VTP is A cross B cross C, and always the vector A cross B cross C gives you a vector that should lie in the plane formed by the vectors in a bracket. In this case, my vector B and vector C, vector B is here, vector C is here. In that plane, that vector A cross B cross C should lie. That's the reason this vector is over here, A cross B cross C. Which means directly I can confidently say that A cross B cross C is not equal to B cross C cross A, or not equal to C cross A cross B. Very clearly the reason behind the vector which you get in a VTP, vector triple product, always lies, the vector VTP A cross B cross C always lies in the vectors in the bracket or parenthesis. In this case this was B cross C. So the vector was over here, A cross B cross C. In this case it will be in the plane of A and C. In this case it will be plane of A and B. So it's not same. Correct? So VTP, always the vector lies in a plane formed by the vectors in a bracket or parenthesis, that is B cross. That's the reason they are never same or equal. Correct? Now we need to find out the value for this. How will we do that? Proof. So we will do the proof over here. Correct? I think the diagram is clear. Point O, OM is vector B, this is A, this is C. Correct? So OLMN is the plane for vector B and vector C, and A cross B cross C lies in the plane of vector B and vector C. Right? So next is proof of vector triple product. Proof of vector triple product. Right? Suppose you have vector A cross B cross C. Suppose this is equal to a vector D, correct? And this I write it as A B plus B C, a linear combination of A and small b are real numbers. Capital B and capital C are the vectors. So what I said, the VTP A cross B cross C is equal to a vector D, which is a linear combination of vector B and vector C with the real numbers. Correct? So, moment I say so, what is my next job? Mention A and B are real numbers and vector B and C are vectors. Correct? Then what we can say? Then we can say A dot B D, the new vector D, which will be equal to 0, a dot product. Correct? Now substitute the value of dot product. So we can say, so what we did over here, took one vector A, dot product with the D, which is A cross B cross C. So A dot AB plus BC, dot product, correct, of vector A with vector D. Put the value of D over here, AB plus BC. What do you get over here? A outside the bracket, A dot B plus B outside the bracket, A dot C is equal to 0. Right? Small a inside the bracket, A dot B plus small b inside the bracket, A dot C is equal to 0. Right? So how we can write this term? We can write this term as A divided by A dot C is equal to minus B divided by A dot B, right? A divided by A dot C is equal to minus B divided by A dot B, as is equal to 0. Take this term on LHS. This LHS, RHS. So what we get? B upon A dot B. Suppose this is equal to P. Say equal to P, correct? Which means, what is the value of my small a? This implies small a is P into A dot C and B is equal to minus P A dot B. A and B are the real numbers. So A will be, what we did over here, A into A dot B plus B into A dot C is equal to 0. So if this term goes on RHS, greater minus sign, that's what I put over here. So A upon A dot C is equal to minus B upon A dot B is suppose equal to a number, constant number, which value we'll find out later. Correct? So which means A is equal to P into A dot C, B is equal to minus P into A dot B. Put this value back in the equation. Put this value, whatever we got. Suppose we say this is equation number 1, equation number 2, this is 3, this is 4. Put the value of small a and small b from equation number 4 in equation number 1. Correct? What we will get then? We will get the value which is A cross B cross C is equal to D is equal to this. Correct? So A cross B cross C is equal to P, small a is P inside the bracket, A dot C into B, correct, minus P into A dot B outside the bracket C. A value is this into B, minus value of B into C. So take P common. So what we have in the bracket? A, C, B minus A, B, C. Bracket complete. P outside the bracket, A dot C outside the bracket B minus A dot B outside the bracket C. Correct? Now my job is to find out the value of P. Correct? For that I'll have to assume something on the LHS which will help me to get the value of P very clear, because we said P is a number, a constant, so we need to know the value of P by which we can get the value of or the proof of A cross B cross C very easy. Correct? For that, what will we say? Suppose we say that A is equal to, if vector A is equal to I, B also is equal to I, and C is equal to G. Correct? This will give me what? A is I cross G. A cross B cross C. So I cross J is equal to, correct? We have the term as it is. So we can write P inside the bracket. A is what? I dot J outside the bracket I minus I dot I outside the bracket G. Right? So first job, what is I dot J? I dot J is K. Correct? What is I cross J was K. What was I dot J? Correct? It will be 0. Minus, what is I dot I 1? So we got the value minus J. Correct? I dot J will be 0, but I cross J will be K. Correct? And this is I dot I will be 1, so minus J. So what is this value? I cross K. We change the order. This will be minus J. This will be minus P into J. Minus minus become plus, and we get J cancel, the value of P to be 1. Right? So put the value of P back in the equation. So what we have the value? We have the value, or we can put it over here. If P is 1, A cross B cross C is how much? A dot C into B minus A dot B into C. So this gives me A cross B cross C is equal to, as P value is 1, A dot C outside B minus A dot B outside C, or ACB minus ABC. This is the value in short for my vector triple product, ACB minus ABC. Correct? So as you change the order, ACB minus ABC. Suppose I want to find out the value of B cross C cross A. Correct? So this was ACB. So here what will I write? First vector as it is. So B vector as it is. Then I have to go for A. Correct? In between should be C. Minus B dot C outside A. So this way we can write down the value for all vector triple product. The last should be C cross A cross B. Should be how much? Correct? First vector as it is, ACB. So this should be C dot B outside A, and the second term should be what we wrote here, ABC. So C dot A outside B. This is the way, in short, we can write down the values for vector triple product, correct, which always lies in the vectors in a bracket or parenthesis. Correct? This ends our half part of the third chapter. Correct? So now next next session should be a lecture which I'll give the notice in 1 or 2 days time. So we will conduct that, and then only we'll go to the remaining half part of the chapter 3. Okay? Thank you.